Yeah, that seems to work.
Everything's working. All right.
Okay, so
Karsten, everybody.
yeah, so I'm here to talk about Cartesi, which is an alternative RISC-V based virtual machine. And just to kind of like keep it short, maybe very short, the Cartesi machine is a RISC-V emulator. It runs completely deterministically. If you start out in the same starting state, you'll end up in the same ending state. It's what we call, let's say, general purpose, as in it implements the full RISC-V 64-bit GC, which means basically you can run Ubuntu inside it if you want to. It's one of those things that's written in C++. It's the LGPL licensed. It runs on Wasm. It runs on Linux. It runs on Mac. And as of a couple of days ago, it runs on MS-DOS, in case you actually wanted to have that. And one of the things that kind of comes with is that it comes with 64-bit memory asset addressability, which means that there's more than enough space in the virtual machine for you to do anything you could possibly think of. And it's been developing since 2018, and it's still being developed. One of the things about this virtual machine is that the entire state of the virtual machine is memory. It can be Merkleized, as in that you can basically represent the entire state of the virtual machine with a single hash. And you can kind of like stop and start it, you can persist it, you can snapshot it, you can roll it back. And that basically means that it's possible to use it in, for example, an optimistic roll-up kind of manner, where you kind of like getting to the point of disagreement and then running one particular step and proving to a blockchain, which then runs one single RISC-V instruction. And I'll build a little bit into it here. And it's kind of programmable. You can adapt it into even ZK environments. We have been trying to do something as crazy as trying to run Linux inside ZK proof using RISC-0 technology, where we basically stuffed our Cartesi machine, our virtual machine, inside RISC-0. And it takes 3 days to kind of ZK proof that you're booting Linux, but at least it works now, right? And basically, I think that the ultimate runtime, kind of like for application, is kind of like a general purpose processor virtual machine that can run the full 64-bit OS. And if you're interested to kind of see the source code of it or the white paper, this is kind of like the links you can go to. So why Cartesi? Why does Cartesi matter, right? And I believe it matters because it's less of a leap for most developers to actually jump into using using blockchain. If you know a bit of TypeScript, if you know a little bit of JavaScript, even PHP or something like that, you can start using Cartesi. Because why can't we actually go in and, let's say, develop application change just with the same mindset that we're approaching things like AWS, Heroku, or Vercel, and so on, right? And one of the things we kind of get for free also was mentioned in my earlier talk, that we get compilers, we get tooling, we get debuggers, we get testing frameworks. We don't need to reinvent this whole thing again. And at the same time, we also get to benefit from that. Well, people have spent the last almost 50 years improving these compilers, these frameworks, these libraries, et cetera, et cetera. And this is maybe a bit of a controversial opinion, but since we have a panel, I thought I might as well get to it, that I believe that if we're looking kind of like back at the EVM in the last like 5 years or more of the EVM, it has kind of like ended up with a trail of dead projects, dead languages, broken developer experience, and I kind of like believe that this course is basically a terrifying and heavy developer experience. And I think that it doesn't help because we also need to have not just completely specialized, almost high priest-like smart contract writers. We also need the average people, the people who want to build, let's say, decentralized message boards or other kind of like small things like this. And this is where I think that Cartesi fits in. Just go with it. I also think that us who's working in virtual machine business and roll-ups and so on, we have many shared challenges. Like, for example, how do we actually talk to each other? We have many different technologies. How do we communicate? How we bridge information between each other? Things about sequencers that are now becoming much more relevant with projects like Celestia and Espresso Sequencer. How do we build those kind of like virtual machine interfaces for block builders, for example, in publisher, proposer builder separation, for example? How do we deal with atomic cross-roll-up transactions in the same way where it doesn't become a frustrating experience for the users? How do we deal with the fact that, well, there's going to be just as many sequencers as there's roll-ups out there, or at least as many as it seems like with technology? Things about indexing, archiving, and also probably a problem that most of us share here. we are really the experts in making rollup or blockchain virtual machines, and there's really nobody out there who can actually really help us to audit it. So maybe we can start the practice of, let's say, starting to audit each other's VMs, et cetera, and things about, is there a way we can use restaking, eigenlayer to kind of like make things cross virtual machine more better, and about prototype sharding, because there's not a lot of blobs available every single time on Ethereum, and kind of like topics that, for sake of collaboration, we can kind of like get to. And yeah, compared to many other talks today, mine is short. So if you want to talk more, you can poke me on Telegram, find somewhere with a Cartesi t-shirt, read more about Cartesi machine or about Cartesi, and that's pretty much it. Any questions?
Sorry? That's a great idea. Let's give a round of applause for Karsten. Any questions? He beat you to it. Sorry. I'll be right there.
Thanks for the talk. I wanted to understand what your system of proving inputs into the VM looks like. So say like the Ethereum virtual machine, or you taking like state from Ethereum, proving the correctness of that within a Cartesi VM?
So the way to kind of think about how input makes it inside a Cartesi machine is basically, you have the state hash, right? It represents the memory. What you basically want to do is kind of stitch the new data that comes in from the Ethereum, in this particular case, into the memory image. So you end up basically with a new hash of the machine state. So then basically everybody agrees on this is the starting state of the machine, right? And then we can kind of like replicate the computation. We can go in and let's say, if there's a disagreement about it, we can find out where did we disagree. But in general, it's just basically like writing into memory. And from point of view of the client, it's basically a JSON RPC call into the virtual machine, write this into memory, that's it. And get the proofs for actually doing so. Does that answer your question?
Yeah, hey, so what I was going to ask is, I really like the part where you told about collaboration, you know, so we have a bunch of VM specialists, and you also talked about doing Cartesi machine proofs using RISC-0, who are also here, so could you talk more about that?
Yeah, so if we're thinking a little bit about, like, it's completely crazy to start up a machine all the time and like booting up Linux and then proving basically the whole execution of that. Because most transaction processing that actually will go in this particular case is that I'll boot up Linux, I'll boot up my application, and kind of like something like AWS Lambda is doing, I'll snapshot at that point. I don't even never ever need to prove that I booted up Linux again. So when I actually get a transaction in that I'm actually modifying, I can prove that tiny, tiny piece, which actually not that many kind of like full-blown general purpose cycles, and make a proof of out of that. So this is one way to kind of like bring, let's say, we don't need to reinvent the entire operating system, let's say, interface. We can go ahead and basically use what's already out there. Of course, as somebody said earlier, the more layers you have, the more probabilities of issues there are. But at the same time, we can also go in and now suddenly do things like, let's say, ZK proving that you can run an entire Rust compilation or kernel build. I have done, let's say, reproducible Docker containers with this. There's many, many interesting things you can do when you can actually have a full machine that's actually complete and can run Linux in it.
Hi, just to be clear, does the user boot up a Linux machine in their browser, computer, or is the sequencer basically a Linux machine?
Yeah, so let me take it from this perspective, right? Like the virtual machine doesn't really care about what sequencer is attached to, right? So it could be Expresso sequencer. We have recently done a demo where we put 17 megabytes of data through the Expresso sequencer, video decoded and showed it with ASCII art, and it happened to be the REC-row, right? So you can run the Cartesi machine in a browser if you want to. You'll naturally take in all the input to kind of like get to the same state, but in most cases, people will want to kind of like, you do it like, for example, it's Optimism is doing it at the moment, where you're kind of optimistically proving to the blockchain, this is the state after a certain amount of inputs. So this is what kind of like optimistic proving is about, right? That after, let's say, everybody has the possibility to dispute what the computation result is, if nobody successfully challenged it, it becomes the computation result. So it kind of depends on how long do you want to wait for the result. Of course, there's possibility to have something like, let's say that you have a node you connect to and kind of check what the latest state is, but there's kind of like also the possibility that these things might eventually also even provide ZK proofs that the execution was actually correct when you're querying about a particular piece of data.
So in the optimistic case, do you have race conditions wherein user A might have taken the current state of the blockchain, whereas user B asked a node which didn't fully know, hasn't sunk up yet, and both of them run their transactions on the same machine?
I don't think there's any, so this is replicated computing, right? So if you're a validator, you're able to replicate the execution completely. If you're dishonest, you'll try to modify it. Like, let's say that I'm getting $1 billion instead of you, right? But the blockchain basically helps ordering the transactions, right? And then basically the Cartesi machine, in this particular case, takes the transactions, runs them in there, updates the state of the machine, or updates some outside state of it, which, for example, could be an IPFS database or something like that. And so there's always an ordering, an exact, let's say, deterministic order of how the virtual machine is supposed to run.
All right. Karsten, thank you very much.
Yep.